Guys, okay, we are going to do January 2019. This is paper 1H. So the front page is the same, formula sheet is the same, and question 1. 21 questions. Write your answers in spaces, show all your working. Right, so question 1, guys, this is actually 7 marks in total, and definitely we can all do these 3 parts. So factorize, I need to take out what's common. There's a 2 because 2 goes into 4 and 6. And there's a p because there's a p in both 4p and 6pq. Then what do I multiply by to get 4p? 2. What do I multiply by to get the 6? 3. And then I need to multiply by a q as well. That'll give me 4p plus 6pq. Okay, question or part B. This times this, this times this, this times this, this times this. Hopefully you've seen many of these, guys. So e times e is e squared. E times minus 5 is minus 5e. 3 times e plus 3e. 3 times 5 minus 15. And this equals e squared minus 2e minus 15. Part C. Solve this. So we need to find y, or make y the subject, if you like. So we have a 5 in the denominator. I don't like that. First thing I'm going to do is multiply across by 5. So I'm going to get 5y equals 2y plus 1. So multiply by 5 removes this denominator. Then I'm going to subtract the 2y. 5y minus 2y equals 3y, and I still have this 1, and then finally y equals 1 over 3, 1 over 3. Question 2. Describe fully the transformation that maps A onto triangle A onto triangle B. Right, guys, so this is one of those ones that's tricky for me to show you how to do because I don't have tracing paper. So the way to do this is, well, first recognize it's a rotation. So there's 3 marks here. First mark is for saying rotation. Then we need to say which direction. Well, we're rotating that way because the A is going to turn on its side, rotate into B, which is clockwise. And how much? Well, it's 90 degrees because we're just going to rotate it. I'll show you exactly why it's 90 degrees in a second, but it's 90 degrees clockwise. And then the center is the tricky bit that we need to find. What's the center point? Now, let me remove this. This is what you do. You get your tracing paper, let's say here, and cover. Just put it something like this. Make sure you cover both of the shapes, and then you draw on the tracing paper. You draw the shape. Like literally draw over shape A. You can even shade it in like this. What I also like to do is I put an arrow up like this, and then I rotate the tracing paper clockwise. Now what you need to do, what I can't do, is decide where's the center. So the center is essentially you're gonna put your pen into one of these points. Now it's going to be somewhere. Let me just do this again. It is going to be somewhere over here, somewhere down here. Exactly where, I'm not sure yet, but you can do it with trial and error. So imagine you put your pen in here. There are various ways to do this with drawing straight lines and stuff, because the easiest way is you stick your pencil into the page, and then you twist, or you turn, or you rotate the tracing paper to the right. And when you do it, if you've put that in the right place, this will line up perfectly with B, and then you know you're right. And then the reason I've put the arrow is because if my arrow has now turned, it was going up and now it's turning right, you can see that's the 90 degrees. It's gone from up to right. It's 90 degrees that way, clockwise. 90 degrees clockwise, so, and the center is then, well, as I say, you need to figure out where the center is. It's actually -2, 3. This was the center there that you should have drawn. Okay, so I'm going to put -2, 3. Then it says on the grid, translate triangle A by vector to -5. So I need to get A, and I need to move it right 2. So I'll pick a corner. You can start with any corner. Let's say this one. I'm going to go right 2, 1, 2, and down 5. 1, 2, 3, 4, 5. Down 5 because it's -5. Then I just do the same with the other corners. 1, 2, 1, 2, 3, 4, 5. And 1, 2, 1, 2, 3, 4, 5. If you recognize that it's just the same shape, you could actually just get away with doing it with one corner. But a translation will give you the exact same shape. It'll just move it to a different point. Now it actually says label it C. So I'm going to call that C. Okay, part C. It says on the grid, enlarge triangle D, this is triangle D, with scale factor 1/2 and center -4, 2. So it actually gives us the center. Now, note, guys, that it says enlarge, but because the scale factor is 1/2, it's actually going to make it smaller. So you're not going to make it bigger, but we use the technical word is enlargement, even if you're actually shrinking it, but we don't say the word shrink. We say enlarge. Anyway, I get my center, and I'm going to draw straight lines. You need a ruler for this, guys. Straight line to the corner. And the point that I want, the new point, is halfway between the center and the corner, because I'm halving it. If the scale factor was 1/3, I'd put it 1/3 of the way. If the scale factor was 2, I'd actually double it, but it's 1/2, so it's here. I do the same with the other corners. So this corner here, where's halfway? Well, it's this guy. It's like over 4 down 2, over 2 down 1, halfway. And then finally, this one. And then where's halfway? Here. Now you actually leave the lines on the paper, guys, because that shows that's your working. That's showing the examiner you're working. Join the dots, obviously, and now you have your new triangle that has been enlarged in inverted commas by scale factor 1/2, so it's actually smaller. Okay, that's question 2. Question 3. There's a biased 5-sided spinner. Biased means it's not the same probability that it will land on each of them. Some of them are different. When the spinner is spun, it can land on red, blah, 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 blah. The table gives the probabilities. Fine. When the spinner is spun once, the probability that it lands on brown is 0.6 more than the probability that the spinner lands on yellow. She spins the spinner 150 times, work out an estimate for the number of times it lands on yellow. Right, so that's actually a bit tricky, guys. It's question 3, and I need to actually think about what's going on here. So it says 0.06 more than it lands on yellow. So firstly, 0.15 plus 0.26 plus 0.33 equals 3, 4, 5, 6, 68, 74. So this equals 0.74. You can do that on a calculator if you want. So that means there's 0.26 left. So 1 minus 0.74 is 0.26. So I need, for brown and yellow, I need 0.26. Now you could just figure it out, guys, because brown has to be 0.06 more than yellow. So you could just say, okay, well, I can see it straight away. Brown would be 0.16 and yellow would be 0.1, because now they add up to 0.26, and brown is 0.06 more. So you can kind of figure it out in your head. If you want to do it the more kind of technical way or algebraic way, you'd say x plus 0.6. So you'd say yellow is x and brown is x plus 0.06. Sorry, not 6, 0.06. So these two together have to equal the 0.26. So 2x, x plus x is 2x, equals 0.2, because I'm subtracting 0.06, and x equals 0.1. So there's my 0.1, there's my 0.16. Then it says work out an estimate for the number of times it lands on yellow. So it's yellow, the probability is 0.1, which means 10% of the time it will land on yellow. And if he spins it 150 times, to find 10%, I just multiply it by 0.1, which is 15. So the answer is 15. 15 is an estimate of how many times it would land on yellow. Question 4. The table gives information about the price of gold. So on the 1st of February 2016 it was this, 1st of March it was this. Work out the percentage increase in the price of gold between February and March. Give your answer to 3 significant figures. Okay, the increase is 1236.50 minus 1126.50, which equals, calculator please, 1236.50 minus 1126.50, which is 110. So the increase is 110. But he wants the percentage increase. So I need to get this increase, this 110, divide it by the original, which is 1126.50. This was the original. Times it by 100, and I get 110 divided by 1126.50, and I'm going to do times 100, and I get 9.7648, let's say. But to 3 significant figures, 9.76. Okay, the price of 1 ounce of gold on the 1st of February was this. The price of gold increased by 19% from the 1st of February to the 1st of July. Work out the price of 1 ounce of gold on the 1st of July. Give your answer to the nearest dollar. Right, so it was 1126.50. And it increased by 19%. The easiest way to just increase by 19%, guys, is to just multiply by 1.19. And that will give me the new price. That's it. That's the easiest way to do it. So 1126.5 multiplied by 1.19 gives me 1340.35. 1340 point, what did I say? 535. Give your answer correct to the nearest dollar. Always read these, guys, because you lose a mark if you don't do that. So it's $1341. Question 5. BCD and AFE are straight lines. Show that BCD is parallel to AFE. Give reasons for your working. Okay, so if I want to show that they're parallel. If they're parallel, then we know some of these rules for angles and parallel lines, like alternate angles, corresponding angles, angles in a straight line, etc. But it says BCD is a straight line. So if BCD is a straight line, then 4x plus 15 plus 3x minus 5 has to equal 180. Because look, this plus this is a straight line. So those two angles together have to equal 180. So using that, I'm going to get x. 4x plus 30x is 34x. 180 plus 5 minus 15 is 170. And then x is 170 divided by 34, which is 5. So x equals 5. Now you can write, it says give reasons for your working. You can say in brackets, as BCD is a straight line. Okay, then if BCD and AFE are parallel, so this is what you're doing. If you're showing that these are parallel, if these two lines are parallel, then 4x plus 15 plus 2x plus 45 must equal 180. Because if they're parallel, then these are corresponding angles. If these two lines are parallel, then these two angles are corresponding angles and should add up to 180. So let's see if they do. Now, if they, well, I've made them equal to 180, but if it's true, then this equals 180. Now I know x should be 5, so when I solve this, I should get x equals 5. If I don't, then they're not parallel. Let's see. 24x equals, this is 15 plus 45 is 60, 180 minus 60 is 120. And then if 24x is 20, x equals 5. So that's correct. They are parallel. I'm just going to write, therefore, it's a fancy way of saying, therefore, they are parallel. They are parallel. Okay. Okay, question 6. So it says complete the table of values. Now you could, guys, just sub 1 in there and sub 5 in there and you'd get the answers, but just to be safe, the best way to do this is using the table. So we go to table, which is number 9. We write in x squared minus 5x plus 6. We press enter. We press enter again because we're only doing one graph. We start at 0 because this guy starts at 0, and we end at 5, and the step is 1 because we're going up in ones. Press enter, and it gives you the values. So we have 0, 6, 1, 2, 1, 2. Let's just put 2 here. Change my color to blue. And then I go down, and I have 5, 6, like this. Then it says on the grid, draw the graph of this. So the graph is basically these points. So I need to plot these points. 0, 6 goes here. 1, 2 goes here. 2, 0 goes here. 3, 0 here. 4, 2 goes there. And 5, 6 goes here. Notice the symmetry. Now I need to join. This is a parabola, quadratic, smiley face. We need to join these. Now note, guys, do not go over to the left here. We have to start at 0 and finish at 5 because that's the domain. So we're going to start here. Now guys, I always apologize about these graphs because my pen is not great at drawing them, or I'm not great at drawing them, but right, you can probably do better than that. The key thing is, guys, you go through all the points, you stop there and there, and it has to go lower than the x-axis here, because this, the minimum would be between 2 and 3, and it would be below the x-axis. But that's, well, I'm not doing it again. That's as good as I can do it. You do it a little bit better. Okay. Then it says, by drawing a suitable straight line on the grid, find estimates for the solution of this, right? These questions, guys, are always difficult. This is how you do it. You look at the left side of this equation, and you look at the function here, and you go, right, they are similar. This is x squared minus 5, but this is x squared minus 5x plus 6. I want to make this look like this. How do I make it look like that? Well, this one's quite easy. I just add 6. So I've added 6 to this. And then you go, well, hang on, you can't just add 6. And I say, well, no, but if I add 6 to both sides of the equation, that's fine. So I've added 6 to both sides, and I end up with the quadratic that I wanted. And then I can use the graph to solve it. Well, I'll do that in a second. So I have x squared minus 5x plus 6 equals x minus 7 plus 6 is just x minus 1. So the line that I need to draw is y equals x minus 1. This, I need to draw y equals x minus 1, this side of the equation. How do I draw it? Well, you might know how to draw it. You can find different points, or you can go back to this. If you're not sure what to do, just draw it like this: x minus 1. Press enter here because I don't need that. I'll start at 0. I can end at 5. Step is 1. That's fine. And then I go 0 minus 1. 0 minus 1. 1 0 1 0. 2 1 2 1. But because it's a straight line, guys, I actually only need 2. I only need 2 lines, or sorry, 2 points. So it will go through these points like this. Now, my solutions are going to be here, which is right there. So that's 1.5, 1.6. So that's 1.6. And this guy here, which is 4.4. So when it says find estimates for the solutions, estimates because my graph's not perfect, so it's not going to be perfect solutions, but my estimates are x equals 1.6 and x equals 4.4, and those I think are actually the answers in the mark scheme, so that means I drew my graph pretty well. Okay, question 7. The table shows the volumes in kilometers cubed of 4 oceans. Right, interesting. Write this as an ordinary number. Right, so guys, you can just do this. You can go menu 1, and you can go 7.18 times 10 to the power of 7, and you get this. It actually gives you the number 718 and 5 zeros. 718 and 5 zeros. How do you do it without a calculator? Well, just put a load of zeros here, and then you go, right, I need to multiply by 10 to the power 7. So I go 1, 2, 3, 4, 5, 6, 7. Stop there. That's where I put the point. Hence the 1, 2, 3, 4, 5 zeros. Right, calculate the volume of these 4 oceans. So I need to add these numbers together. Now guys, again, without a calculator, that's kind of tricky. But with a calculator, this isn't tricky at all, because I just do that plus, well, that was the Southern Ocean. The Indian Ocean, 2.64 times 10 to the power of 8 plus 3.10 whatever times 10 to the power of 8 plus 1.88 times 10 to the power of 7. Press enter and I get this. Does it ask for it in standard form? Well, it doesn't, but let's write it like that anyway. So it'd be 6 with 1, 2, 3, 4, 5 zeros again. 1, 2, 3, 4, 5, which is equal to 6.646 times 10 to the power of. Now I need to do this, guys. It's 1, 2, 3, 4, 5, 6, 7, 8. So it's 10 to the power of 8. Okay. Finally, the volume of the South China Sea is this. Write this in standard form, right? So guys, this is, as far as I'm concerned, a nice, easy question, especially if you have your calculator. So it's 9.88 times 10 to the power of 1, 2, 3, 4, 5, 6. 10 to the power of 6. Okay. Question 8. The area of the triangle is 12 centimeters squared. Work out the perimeter of the triangle. Give your answer correct to 3 significant figures, right? It's an isosceles triangle. The area is 12. Okay. If the area is 12, that means trying to figure out how to do this. That means that, okay, let's use Pythagoras' theorem. If I draw a line straight down, this is 2.5 because it's half. That's 2.5 and that's 2.5. And this side here, I don't know what it is, but I do know, let's call it, let's call this y. So I can say x squared, or sorry, from Pythagoras' theorem, y squared plus 2.5 squared equals x squared. And I can say that y squared equals x squared minus 2.5 squared is 6.25. And then I can say y is equal to the square root of x squared minus 6.25. So that is the height of this triangle. So I can say base area of a triangle is equal to a half base times height. The base is 5, so it's a half times 5, times the height, which is this. The height is y, which is the square root of x squared minus 6.25. Now it says, guys, that this is equal to, it says the area is equal to 12. So I'm going to say this equals 12. And then I'm going to find x. This is a slightly tricky question. So I'm going to find x and then just add x plus 5 to give me the perimeter. So this is equal to 12, which means the square root of x squared minus 6.25 is equal to, I'm going to multiply by 2 and divide by 5. So that will remove this 5 over 2. Multiply by 2 and divide by 5. So 12 multiplied by 2 divided by 5 is 24 over 5, or 4.8. I'll put 4.8. Square both sides. X squared minus 6.25 equals 4.8 squared. x squared equals 4.8 squared plus 6.25, and then x is equal to the square root of that. So I'll put, let's do that first, 4.8 squared plus 6.25, which is that, or this, 29.29, and the square root of 29.29, square root of the answer is 5.412. 5.412. Therefore, right, so that's that's not easy, guys, what I've done there. So I have my height is 5.412. Sorry, I have my x is 5.412. So the perimeter, I'll write it here just so we're clear. The perimeter is 5.412. That's x, plus 5.412. That's the other x, plus 5, because there's a 5 here. So it's this plus this plus this, which is equal to 15.824. 15.824 to 3 significant figures, 15.8. So that is 15.8. Okay. Question 9. Table of speeds of 60 cycles. This is a frequency table, so obviously between 20 and 30 was 24 cycles. I assume that means like a bicycle. Okay, complete the cumulative frequency table. So between 0 and 10 was 3 people. We know that. That's the first one. It's the same. Between 0 and 20, we need to add the 2 of them because there's these and these. So that's 19. 0 and 30, I need to add them all. So that's 43. Then between 30 and 40, I need to add another 10, 53. Then I need to add 5, 58, and add 2, 60. So hopefully we know how to do this, guys. Just add them up, get your cumulative frequency table. Then I need to draw the graph. So 0, I'm going to start at 0 because that's the first one here. But I need to look at the 10 for to put my point. So my first point is at 10, 3. My second point is at 20, 19. My third point is at 30, 43, etc. So I'm going to go to 10, 3, which is here. I'm going to go to 20, 19, which is here. I'll put a point at 0, 0 as well, guys. 30, 43. 30, 43. 40 is 53. 50 is 58. And 60 is 60. Now we join these up, making a nice curve. Now again, guys, I struggle with this, and it's important that you get it right, because like the quadratic question, oh, I don't like that. Like the quadratic question, they're going to ask us questions about this, and if your graph isn't accurate, then the answers might be wrong. Now obviously here, guys, I haven't quite got it right. Maybe you want to something like that. Maybe erase a little bit of that. Okay, that'll have to do. Then it says use your graph to find an estimate for the interquartile range of the speeds. So how do I get the quartiles? Well, I go to 60 and I divide it by 4, which is 15. I go to 15, I go across, and I go down. Now this looks like, okay, let's just say it's 18. Then I go to the upper quartile, which is at 45. 3/4 of 60 is 45. There, and I go down. So this is Q1 and this is Q3. Q1 is, let's go with 18, and Q3 is 32. So I'm going to do 32 minus 18. 32 minus 18. This counts as the working, guys, so show these straight lines on your graph. 32 minus 18 is 14. So the interquartile range is 14. Question 10. So we have a triangle ABD, and the point C lies on BD, and all of this information, but you can basically see it from the diagram. Calculate the size of BAC, right? So what he's asking for is this angle here. This is what we're trying to get. Let's call it X. Okay, so to get this angle, well, let's think about, I want you to think about two triangles here. So we have a big triangle. This is a big right-angled triangle. And then we have a smaller triangle here, which would be this one. And then similar, that color, I'll make that half pink, half orange, or actually I'll do this. Just as clear, that's for both. Okay, now let's look at the small triangle first. If this angle's X, let's call this Y. So if I can get this side here, then I can just use SOHCAHTOA with the big triangle. So let's get the small triangle first. So small triangle, I'm going to say tan of 20. I'm choosing tan because I have the opposite and the adjacent. So TOA, opposite over adjacent. So tan of 20 is opposite over adjacent, which is 13. So that means Y equals, multiply by 13, 13 tan 20. So Y is equal to 13 tan 20, 13 times tan 20 is 4.7316. 4.7316. Let's call this 4.7316. Okay, now let's look at the big triangle. So, okay, I'm going to do this, and I'm going to do this. Okay, this is a right angle. This length now is 8, because this side BC is 8. So it's 8 plus 4.7316, which is actually 12. This is 12.7316, and this is 13. Okay, so let's call this angle theta. Often we use the letter theta for angles. So now again I'm going to use tan, but this time I'm going to use it to find an angle. So I'm going to say tan of theta is opposite 12.7316 over adjacent, which is 13. Theta is then, we need to use the inverse tan. So I need to press shift tan for inverse tan, and I'm going to put 12.7316 over 13, and I get 44.4. It's one decimal place and 4 zeros, so that's fine. 44.4. 44.4 degrees. But to finish it, this X is not the full theta, It's the theta minus the 20 degrees. So I'm going to say x is equal to my 44.4 minus 20, which is 24.4. So x is, this is wrong, x is 24.4. So we have algebraic fractions. I need to write this as a single fraction. So what do? I need a common denominator. The common denominator is going to be 3 times 2x, which is 6x. So I'm going to do, let's write this out properly, guys. It's 5 over 3 minus x plus 2 over 2x equals, my common denominator is 6x. So this is 6x minus this is 6x. Why did I choose 6x? Well, I need something that these both go into. The easiest way to do it is just multiply. 3 times 2x is 6x. Now, it's just like fractions, guys. Equivalent fractions. What did you times 2 by to get 6x? 2x. So what do I times 5 by? Also 2x times 2x, which gives me 5 times 2x is 10x. And then, similarly, what did I multiply 2x by to get 6x? 3. What do I multiply this by to get 6x? Same thing, times 3. So it's going to be 3x plus 6. This times 3 and this times 3. Now just be careful, guys. I'm going to put that in a bracket because this minus is going with both of these. So now I can make it a common, I could just make it a single fraction because he wants it as a single fraction, but because the denominator is the same, that's fine. Now I have 10x minus 3x minus 6, which gives me 10x minus 3x is 7x, and minus 6 over 6x, done. That's it. It's a single fraction and it's in its simplest terms. I can't make it any more simple. Okay, question 11. Question 12. Find dy dx. So the curve has this equation. I need to find the derivative. So to find the derivative, dy dx, I multiply by the power 3 times a third. Now 3 times a third is 1. So it's just going to give me 1x squared because I subtract 1 from the power. 9x becomes 9 and 1 becomes 0. So it's just x squared minus 9. That is my derivative. Find the range of values for which c has a negative gradient. Right, guys. Negative gradient means dy dx is less than 0. That's what dy dx is. It's the gradient. It's the gradient of the function. So where is this less than 0? Well, it's where is x squared minus 9 less than 0. Now guys, this is now a quadratic inequality. Not easy, but we have a calculator. I'm going to go to inequalities here. The degree is 2 because it's a quadratic. And I'm going to use 2 because it's less than. So be super careful. Press 2. It's 1x squared, 0x, because there's no x term, and then minus 9. Press enter. And this is my answer. X is bigger than negative 3 and less than 3. X is bigger than negative 3 and less than 3. Now guys, what he wants you to do is, to get all the marks, you have to factorize this. So you gotta go, what are the factors of x squared minus 9? Well, this is something that I see coming up over and over again, guys. This is a difference of 2 squares. It's x plus 3 times x minus 3. When you see x squared minus something squared, that's this formula, x squared minus b squared equals, or sorry, a squared minus b squared is a plus b times a minus b. Learn that, remember that. Where's this less than 0? Well, that's the answer from the calculator. If you wanted to draw it, I always like to do it, guys. I like to draw quadratic inequalities, or draw the quadratic curve to see what's going on. The roots are going to be at -3 and 3. And when you draw it like this, doesn't matter too much what it looks like, you see, where is this curve less than 0? Well, it's less than 0 here and here. Bigger than -3 and less than 3. Okay. Question 13. All the students in year 11 at a school must study at least one of geography, history, and religious studies. There are 65 students in the school. Of these students, okay, blah, blah, blah. I can read that in a second. Using this information, complete the Venn diagram to show the number of students in each region, right? How many marks are they giving us? 3 marks. Not bad. 15 study geography, history, and religious studies. So they give us that one first, which is nice. I put that in the middle. 21 study geography and history. Now, where's the geography and history section? Well, it's this section here. And he says 21 are in this section, but I have 15 already, so that means I must put 6 here. 16 study geography and religious studies. That's what region? Well, it's this region here. 16. I already have 15 there, which means I can only put 1 here. 30 study geography. Now that's the whole circle. I have 15, 21, 22. What's left? 8. So just notice the difference, guys, between 30 study geography and 18 study only religious studies. So that means 18 is going here, because this is the only religious studies section. If it was here, that's religious studies and history, so just be careful. And then he says 37 study religious studies. Okay, so that's this whole circle, 37. I have 18 plus 15 is 33. 34, that must give me another 3 here to give me 37 in total there. But I'm not finished, guys, because it says they all must study at least one of these subjects. So what goes here? Well, what's left out of 65? So I need to add up all of these. So I'll do it in my head, guys. 14, 15, 30, 48, 51. What's left to get to 65? From 51, it's 14. 51 plus 14 gives me 65. Nothing goes on the outside because they must study at least one. At least one of them. Okay, that's part A. Part B. A student in year 11 who studies both history and religious studies is chosen at random. Work out the probability that this student does not study geography. Right, so this is tricky, guys. This is conditional probability. It says a student who studies both history and religious studies. So he has to be, this person has to be in here. So let's shade all this in, color this in. He has to be in here because it says, this is conditional probability, this is the condition. He does study religious studies. Oh, sorry, hang on, I've done that wrong. He studies both. See, this is why we need to be extra careful. Both history and religious studies. So he does both of them. So he's in here, this section. Okay. So he's one of these 18. So the answer is going to be out of 18. The probability he does not study geography. So it's out of 18 because there's only 18 people. And then we're like, okay, out of these 18 people, as you said, it's one of these 18 people, what is the probability he does not study geography? Well, look, this guy does not, these 3 do not study geography. He does, these guys do study geography. These guys don't. So it would be 3 out of 18. That's the answer. Okay, question 14. T is directly proportional to the cube of r. Straight away, I'm going to write T is directly proportional to the cube of r cubed. Then, and you can skip that line, guys, if you want, and just write T equals k r cubed. So the proportional you can change for equals k. I'm not going to go into too much detail about why this is the case, guys, but this is how you do it. T is this when r is this. So we need to, the first goal is to find k. So we sub in these values. 21.76 for k for T, and 4 for r. That's k times 4 cubed, which is 64, by the way. So 21.76 equals 64 k. And then we find k by just dividing 21.76. Well, I'll write it down, 21.76 over 64, divide by that, and I get k is equal to 21, hang on, need to go back to this, 21.76 divided by 64 gives me 17 over 50, or 0.34, so k is 0.34. The formula is then just, it's just basically finding k, but I have to write the formula. The formula is then T equals 0.34 r cubed. This is the formula here. This is the formula, but we need k. So it's the formula with the value for k. Once you have the formula, then this bit's easy. Work out the value of t when r is 6. Well, t equals 0.34 r cubed, but you were saying where r is 6, so it's just 6 cubed. So it's this times 6 cubed, like that, gives me this s to d 73.44. 73.44. Okay. Question 15. This is hard. The total surface area of a solid hemisphere is equal to the curved surface area of a cylinder. The radius of the hemisphere is r. The radius of the cylinder is twice the radius of the hemisphere. Okay. The volume of the hemisphere to the volume of the cylinder is 1 to m. Find the value of m, right? I genuinely don't know how to do this yet, but as I do it, I'm guessing or hoping I'm going to be able to figure it out. So the total surface area of a solid hemisphere. Okay, let's do the hemisphere first. Hemisphere. So the surface area is equal to. Now we have the, I'm going to scroll up here, guys, to the formula sheet. These are the formulae that we're going to use. This, I'll actually, let me just do this. I'll bring it down here. So we have these formulae that we need. Okay, I'll put them, let's put them somewhere here. Okay, so the surface area of a hemisphere is, we've got a problem. It's not the surface area of a sphere. It's half of a sphere, because a hemisphere is half of a sphere. So instead of 4 pi r squared, it's 2 pi r squared. Because it's half of this. Half of 4 pi r squared is 2 pi r squared. But think about a hemisphere, guys. If you, I don't know, cut a ball in half, what happens is, because it's solid, or imagine you had a hemisphere made of gold or something, half a ball of gold, there's, the surface area is actually the entire surface. So the bottom of the hemisphere is actually a circle. Just think about it. You've cut it in half. So I need to add the area of the circle. So it's plus pi r squared. That's the half the area, half of this, plus the circle. So that's actually 3 pi r squared. So the surface area of a hemisphere is 3 pi r squared. Okay, I didn't actually know that, but once you add them, obviously, fine. So you don't need to learn off by heart the surface area of a hemisphere, but you need to understand what's going on. It's half the sphere. It says this is equal to the curved surface area of a cylinder. The cylinder, the curved surface area, so just be careful, there's the surface area and the curved surface area, CSA, that is equal to pi r squared h. But wait, it says the radius of the cylinder is twice the radius of the hemisphere. Okay, so if I'm using r for the hemisphere, I'm going to use 2r for the cylinder. So the curved surface area of the cylinder is 2 pi radius times h, but the radius that I'm going to use now is 2r because I've used this r here. That's confusing to begin with. So it's 2 pi r h. Okay, so right, this is now 4 pi r h. It says these are equal. They are equal. So 3 pi r squared equals, and actually guys, I'm going to write this first. So 4 pi r h equals 3 pi r squared. The reason I'm doing that is because I actually want to get h. What is h in terms of r? So firstly, divide both sides by pi. I can cancel the pi's. Hopefully that's okay. And then I can divide by 4 and divide by r. So it's 3 r squared over 4 r, which is actually equal to 3 r over 4. So the height of the cylinder is 3 r over 4. Okay, then it says the volume of the hemisphere, the ratio of the volume of the hemisphere to the volume of the cylinder is 1 to m. Find the value of m. Okay, so for the hemisphere, I'm going to continue down here. Hemisphere, the volume of a hemisphere is, the volume of a sphere is 4 over 3 pi r cubed. So the volume of a hemisphere is 4 over 6 pi r cubed, because I've divided this by 2. If you divide it by 2 instead of 4 over 3, you 4 over 6. Think about what's a third divided by 2? It's a sixth. Okay, the volume of the cylinder, again guys, FYI, this is a very tricky question. The volume of the cylinder is now pi r squared h, but again, the r is 2r for the cylinder. It's pi r squared h, and the h, instead of putting h, I'm going to put this 3r over 4. Okay, still think I'm going in the right direction, but I'm not 100% sure it's going to work out, but we'll see. If it doesn't, I can always make the video again. This is going to be now pi times 2r times 2r is 4r squared. And this is 3r over 4. It's 4r squared because you have to square the 2 as well. The 4's cancel nicely because I'm multiplying by 4, I'm dividing by 4. And I'm left with pi, sorry, I'll do the 3 first. So I'm left with 3 pi r cubed. Okay, nearly done. So this is the volume of the hemisphere, volume of the cylinder. He is saying the volume of the hemisphere, 4/6 pi r cubed, to the volume, the ratio of the volume of the hemisphere. Let me do that again. Volume of the hemisphere to the volume of the cylinder can be written in the form 1 to something. So basically, I just need to make this, I need to kind of change the ratio into 1 to something. So look, ratios work a bit like fractions. So I can say, I can divide both sides by r cubed, and I can divide both sides by pi. So the ratio is now 4/6 to 3. I can multiply both sides by 6. So now it's actually 4 to 18. And then I can divide both sides by 4. So it's 1, 2. This divided by 4 is 4.5. So m is 4.5. Right. Obviously, guys, very challenging question. Normally, a question like that I expect more towards like in the 20s, but fair enough, they've given it to you as question 15. And I think that is right. So there you go, question 16. Rationalize the denominator. How do you rationalize the denominator? So guys, this is one, like, again, not easy, but there's a rule that you can learn, and we can all make or get the first step here. To rationalize the denominator, you multiply above and below by the conjugate of the denominator. The conjugate is a plus, so it's just whatever this is, change the sign. So it's a plus root 4b over a plus root 4b. Now you might ask, why do I do that? Well, you can do that because you're just basically multiplying by 1. If you multiply anything by 1, it doesn't change it. If you multiply your bank balance by 1, nothing happens. So that's fine, I'm allowed to do that. You'll see now when I multiply it out why it works out quite nicely. So I have to multiply the top and the bottom separately, and it's the old first times the first times the second times the first, second times the second method, and I have to do it with both the numerator and the denominator. It's annoying, it's not easy, but we can all do it. A times a is a squared. A times root 4b is a root 4b. Root 4b times a is also a root 4b, and root 4b times root 4b is just 4b, because root x times root x equals x. Whatever's in the root, if you square it, you just get itself. Okay, that's the numerator. The denominator is then a times a is a squared. A times root 4b is plus a root 4b, and this is the key. Minus root 4b times a is minus a root 4b. So these two cancel, and it gets rid of the root, because root 4b times root 4b is 4b, but it's minus 4b here. And then all I have to do is simplify both. So the numerator simplified is a squared plus, I need to add these two, a root 4b plus a root 4b is 2a root 4b. Now, yeah, some of this mathematical language may not be familiar to you, but it's the same rules. If you just have x, y, z plus x, y, z, you get 2x, y, z. So that's all we've done. This plus this is 2 of these. Okay, let's get rid of that. Delete. Okay, that's my numerator. And then finally, my denominator, as I said, these two cancel nicely because it's just the plus this minus this is 0, and I'm left with a squared minus 4b underneath the line. I can't do anything more with it. That's it simplified. There's nothing else I can do. Okay, part B. Given that root y over x to the power of negative 5 is equal to this, find the value of m. Okay, so first thing, if I have a negative power, what I do is I flip this upside down and I make it a positive power. So I can turn this into the square root of x over y to the power of 5. So now it's a positive power. And I have my x over y, which I want. Then I have what I call flower power. So this is a root and this is a power. So this I can actually write as the power is 5 and the root is 2. There's like kind of a little 2 there that we don't write, but the square root is the second root. So if it's a 2 there, if that's the root, I do 5 over 2. And then that's just the same as x to the power of 5 over 2 over y to the power of 5 over 2. I can do that. If I have this to the power of this, it's just this to the power and this to the power. So m is 5 over 2. I can't believe they've only given me 1 mark for that. But again, c'est la vie. Right, question 17. Find the value of x. Okay, I think, guys, this is 5 marks. Okay, it's not as easy as I was hoping for. To find this value, okay, my first thought is, can I use the sine rule? If I'm going to use the sine rule, I need this on the opposite side, and then this on the opposite side, but I don't have this side here, so I can't use the sine rule. Can I use cosine rule? No, because I know I need the 3 sides. So basically, I need this side AC. I'll call it y. How am I going to find it? Cosine rule. This is the cosine rule. So I'm going to just find this side and then I'll use the sine rule. So that's kind of why I looked at the number of marks, guys. I wanted to know, can I do this in just one go? Or do I need to use 2 different rules, or at least the same rule twice? Because it's 5 marks, that made me think, yeah, I need to use 2 rules. So first I'm going to get y. So I'm going to have y squared equals 4.1 squared plus 5.3 squared minus 2 times 4.1 times 5.3 times cos of 110. Now that is straight out of the formula booklet, guys. You all can definitely do that, right? It's this squared plus this squared minus 2 times this cos of this. It's in the formula booklet. And then I can just work this out on my calculator. So this is 4.1 squared plus 5.3 squared minus 2 times 4.1 times 5.3 times cos of 110, and that equals 59.764. 59.764, which means y is the square root of that, square root of 59.764, which is the square root of the answer is 7.73. So this is 7.73. Now maybe I've rounded too much here, guys, but it is an O. I'll still put it in. 7.7307. As I say, I'm not going to round well, I'll round a bit, but I'm not going to round too much until the end. Then I'll do 3 significant figures. Now I have y, I can use the cosine rule. Or sorry, the sine rule. I could actually use the cosine rule, but I think the sine rule is easier at this point. So I'm just going to say sine x, pick the thing you're looking for first, the sine of the angle, over 5.3, the opposite side, so this angle goes with this side, equals this angle, sine of 110, over this side, which I now know is 7.7307. And then I just need to solve this. So I say sine x equals multiply across by 5.3, 5.3 sine 110 over 7.7307. And then I'm just going to go straight to x, is the inverse sine of this. So just be careful. Inverse sine, shift and sine, and then do this. 5.3 times sine 110, over 7.7307, close all my brackets, enter, and I get 40.108, 40.108. He said 3 significant figures, so I'll put 40.1 centimeters. 40.1 centimeters. Okay. Question 18. On the grid above, sketch the graph of y equals f a half x. So this is f of x, this is f of a half x. All right, so this one's tricky, guys, because when the number with the transformation, like the half, is inside the bracket, I need to multiply the x coordinates, because it's inside the brackets, I multiply the x coordinates, but because it's well, because it is the x coordinates, or because it's horizontal, the scale factor is actually not a half, it's 1 over a half. So it's 1 over this, which is actually equal to 2. So whatever that number is, it's 1 over that. It's the reciprocal of that. So if it was 3x, you multiply by 1 over 3. If it's 5x, you multiply by 1 over 5. If it's a half x, you multiply by 1 over a half, which is 2. So what this is going to actually do is it will, well, it'll stretch it. It'll stretch it by scale factor 2. So I'm going to multiply the x coordinates by 2. Now my x coordinate here is minus 2. Multiply it by 2, and I get there. My x coordinate here is 1. Multiply it by 2. Sorry, negative 1 multiplied by 2 is negative 2. This guy is 0 multiplied by 2 is still 0. This guy's 1 multiplied by 2 is 2, so that's my minimum. This guy is 3 multiplied by 2 is 6, and this guy's 4 multiplied by 2 is 8. So you can see it's a stretched version of the quadratic. Apologize again for my graph, but that has to be the minimum there. And then, okay, that's not too bad. Right, that is part A. Part B. The graph of f of x plus k is shown on the grid. Find the value of k. Right, so x plus k, this is like a horizontal translation of k. So it has moved that way. It's a translation. It is moved that way by k. How much has it moved? Well, the minimum, if you remember, well, let's just go back to it. The minimum here of the original one, not the blue one that I've drawn, was at 1. So it's just moved to the left. It was at 1. It was here. And he's just moved to the left to here. 1, 2, 3. So k is equal to 3. That's why it says write down. Doesn't require too much working. Okay, question 19. G is the function with domain x is greater than negative 3, and g of x is this. Write down the range of g minus 1. So it's greater, x is greater than negative 3. So what I need to do is, it's the range of g minus 1. So the range of the inverse function is the same as the domain of the function. So let me just write that so we're clear, guys. Range of g minus 1 is the same as domain of g. So the range is just g of x, g of minus 1, or y you could use, is greater or equal to minus 3. It's the same as this, but not x, it's y, or g minus 1. Express the inverse function g minus 1 in this form, right? So this, guys, is one of those not nice inverse functions. So it's 4 marks. It's not nice because it's a quadratic. And the only way to get the inverse of the quadratic is to complete the square, which, let's face it, no one likes doing. So this is x squared plus 6x. To complete the square, I need to half this. So it's x plus 3. If you don't know how to complete the square, guys, ask your teacher to show you, because I'm not going. You won't understand it in this one example here. But this is how you do it. You half this to 3. Half 6 is 3. Then you do x plus 3, and you square that. And this gives me x squared plus 6x plus 9. I don't like the 9 because there's no 9 here, so I have to subtract 9. I subtract this squared. So it's minus 3 squared, or minus 9. So I can then say, let y equal x plus 3 squared minus 9. Then I swap the x and the y. Swap. Do this first, because you got a mark for it. X equals y plus 3 squared minus 9. I have swapped x and y. And then I need to make y the subject. So I'm going to say x plus 9 equals y plus 3 squared. Then I'm going to say y, I'm just going to swap them. I'm going to, instead of saying this equals this, I'm going to say this equals this. So I've done nothing there, just change them around. Then I'm going to get the square root of x plus 9. So y plus 3 equals the square root of x plus 9. And then I'm going to say y is then equal to minus 3, because I'm going to subtract this 3, minus 3 plus or minus root x plus 9. Now we've one slight issue here that we have to address. It says minus 3 plus or minus square root of x plus 9, but the inverse function has to be greater than negative 3, because we wrote it here. The inverse function has to be greater than negative 3. Therefore, you can write that here, guys, if you want. G minus 1 is greater or equal to negative 3. That means this inverse function, which is g minus 1 of x, with this arrow here, this is the way they want us to write it, but it's the same thing. This is minus 3 plus the square root of x plus 9. Not that the minus is not included, because that would actually make it then less than negative 3. So that's complicated. Okay, question 20. A bowl contains n pieces of fruit. Of these, 4 are oranges and the rest are apples. 2 pieces of fruit are going to be taken at random from the bowl. The probability that the bowl will then contain n minus 6 apples is 1/3. Work out the value of n. Right, this is a tree diagram question, guys. And to be fair, not a particularly nice one. In fact, it's not nice at all. So let's try and draw it. This is the tree. I'm going to write start here. I like to write start. There's a bowl and it contains oranges. We're going to take 2 pieces of oranges, or sorry, 2 pieces of fruit. It could be an orange or an apple, O or A. Then we're going to take a second piece of fruit, and that could also be an O or an A. And then this guy, if we get an apple, we're still going to take a second piece of fruit. That could be an O or an A. So that's my first part of my tree. Now, unfortunately, there's no marks for that yet, but we'll get there. There's n pieces of fruit in the fruit bowl. 4 are oranges. If there's 4 oranges and there's n pieces of fruit, what's the probability that I'll get an orange? Well, it has to be 4 out of n. That bit's fine. If 4 out of n are oranges, how many, if there's 4 oranges, let me give you another example. If there was 20 pieces of fruit and 4 were oranges, how many would be apples? Well, obviously 16. So similarly, if there's n pieces of fruit and 4 are oranges, it has to be this minus 4. So it's n minus 4. So that's how we know that the probability of choosing an apple would be n minus 4, because there's n minus 4 apples, out of n. Let me remove this just so no one thinks that's part of the question. I can leave that. Okay. Now, if I choose an orange, how many oranges are left? 3, because I've already chosen one. And how many pieces of fruit are left? Well, it's n minus 1, because I've taken an orange, so there's 1 less pieces of fruit. So it's 3 out of n minus 1. How many apples are there? Well, if I've taken an orange, there's still n minus 4 apples, and it's out of n minus 1, because we've taken a fruit similar to that. If I take an apple, how many oranges are left? Well, there's 4, because there's still 4 oranges because I took an apple. How many pieces of fruit? N minus 1, because again, we're down a fruit because I've eaten an apple. Similarly, this is going to be out of n minus 1, but now this is, there's n minus 4 apples, and if I actually take, if I eat an apple, I'm now going to have n minus 5 apples. So this would be n minus 5 over n minus 1. Okay, so first step, or second step, done. Not obvious or easy, but there we go. Now, next part of the question says, the probability that the bowl will then contain n minus 6 apples is 1/3. So how can this bowl, so these are the 4 scenarios: orange, 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 apple, apple, orange, apple, apple. How could this bowl now contain n minus 6 apples? Well, think about it. We had n minus 4 apples. If we eat an apple, let me draw an apple. That's a very poor apple. Let's say we eat an apple. There, that's your apple. If you eat an apple, if there's n minus 4 apples and you eat one, how many are left? Well, now it's n minus 5. Okay, what if you eat another one? I really need to learn how to draw apples. If I eat another apple, that one's maybe a bit better. If I eat another apple, how many do I have left? Well, now it's n minus 6, because I'm subtracting 2. So I've eaten 2 apples. That's the only way I can get to n minus 6. So that is the kind of key of realizing that the branches we want to take are these two, the apple root. So it's like just a fancier, complicated way of saying the probability that he takes 2 apples is a third. But he's written it in a way like just to confuse us. The probability that the bowl will then contain n minus 6 apples. So it's this one, it's this root. So I can say n minus 4 over n times n minus 5 over n minus 1. Remember, we multiply along the branches. This equals a third. And now I just have to solve this, which isn't actually that easy to do, but let's try and solve it. So it's obviously a quadratic. Okay, I have n minus 4 times n minus 5 equals, so that's the numerator here. Okay, let's go n times n minus 1 equals 1 over 3. I'm going to cross multiply, so I'm going to say 3 times this over n times n minus 1. 3 times this equals 1 times this. Oh, sorry, hang on. I should have done that in one go. Okay, let me say that again. I'm doing 3 times this equals 1 times this. N times n minus 1. Okay, now multiply out these two brackets. N squared, this is my, this times this, this times this, this times this, this times this. N squared minus 5n minus 4n plus 20. That equals n times n is n squared minus n. Multiply out by 3. 3n squared minus 15n minus 12n plus 60 equals n squared minus n. Bring everything to the left, make it equal to 0. 3n squared minus n squared is 2n squared. Minus 15n minus 12n is minus 27n. Plus this n is minus 26n. Plus 60 equals 0. Just make sure, guys, you can follow what I did there. I went pretty quickly. Divide by 2, because I can. N squared minus 26n plus, sorry, dividing by 2. Divide everything by 2. 13n plus 60 equals 0. I'm going to go over here. This is n squared minus 13n plus 60 equals 0. So we have another factorizing quadratic question, guys. So how do I factorize this? Well, factors of 60 that are going to give me 13. So I could do 6 times 10. That's not going to do. That's not going to work. 15 times 4. Oh, sorry, guys. I've made a mistake. Bad mistake. I nearly made it twice. Divide by 2. This divided by 2, this divided by 2, this divided by 2 equals 0. I recognize that because I saw I wasn't going to factorize. So I have n squared minus 13n plus 30 equals 0. Remember, you have your calculator to help you. I'm going to do this without the calculator. I have n and n. Factors of 30, that'll give me 13. Well, I have 5 and 6, that's no good. 15 and 2, normally I'd say great, 15 and 2 works, but because this is plus, the signs have to be the same, so 15 and 2 won't work because it'll give me 17. So it actually has to be 10 and 3. So my signs are the same, so it's minus. N minus 10 times n minus 3 equals 0. Therefore, n equals 10 or n equals 3. Now let's just go up and have a look at this situation. Is it possible that n can equal 3? Well, let's look. it says that the probability that the bowl will contain n minus 6 apples is a third. Well, 3 actually in this case doesn't make any sense, because 3 minus 6 is negative 3. So you can't have negative 3 apples. So n can't be 3. So we have to say at the end n equals 10. That is the only answer. Okay, yes, that is it. As tree diagram questions go, that's pretty bad. I think, guys, thankfully, this is the last question. 21. And this question, I think, if my memory serves me right, is an example of the very last question not actually being that bad. So often students get to the last question and think, well, I can't do this. This is too hard. But I'm going to show you that this one actually isn't too bad. So these are 3 consecutive terms of an arithmetic sequence. Arithmetic means we can add the same number to get from this to this. Plus d, the common difference, plus d, the common difference. That means the difference between this and this is the same as the difference between this and this. So I can say 8x plus 2 minus 2x plus 3, or plus 23, that will give me the difference between these two, has to equal the difference between these two. 20x minus 52 minus 8x plus 2. Now, just be careful with the brackets. So it's minus brackets here. So these two have to be equal. So I'm going to say, because they're both common difference, that's what an arithmetic sequence is. 8x plus 2 minus 2x minus 23 equals 20x minus 52 minus 8x minus 2. Careful with the brackets and the minus. 6x, this is 8x minus 2x is 6x. 2 minus 23 is minus 21. That has to equal 12x minus 54. Now, these guys are both the common differences. Now, if it is an arithmetic sequence, I can solve for x. I can say 12x minus 6x, and I can say minus 21 plus 54. So I've added the 54 and I've subtracted the 6x. This is equal to 6x minus 21 plus 54 is equal to 33. So x is equal to 33 divided by 6, which is actually 5.5. You can do that on your calculator, guys. 33 divided by 6, 33 divided by 6 is 11 over 2, or 5.5. Now, we're nearly there. The common difference equals 6x minus 21. We know that because it was the difference between this and this. This is our 6x minus 21. This is our common difference. It's also this. So you can actually sub it in. We're going to sub 5.5 in here, but you could actually sub 5.5 in there and you'll get it. Common difference equals this, equals 6 times 5.5 minus 21. We know 6 times 5.5 is 33 because we've just done it there. 33 minus 21 equals 12. Therefore, we have proved that the common difference is 12. There it is, it's 12. So I'm going to write QED. That stands for Quod erat demonstratum, which is Latin for which was to be proved. So it's like, I have proved what you asked me to prove. So I'm not saying that question's easy, but I'm saying it's a question 21 that's not impossible. Okay, that, guys, is the paper done. Yep. So hope you found it not too bad, and I'll see you for the next paper.